Silvia Terribili. En vanavond hebben wij een speciaal programma met een gast vanuit de States. Dat is Dr. Abdullah Al-Fahad. Hij is postdoctoraal associate van de National Aeronautics and Space Administration, de Goddard Space Flight Center. Hij kreeg een PhD in Climate Dynamics bij de George Mason University in 2020. En hij werkt nu voor NASA, Goddard Space Flight Center, het Global Modeling and Simulation Office. Hij houdt van werken met numerische modellen en issues gerelateerd tot de fysica van de atmosfeer. Hij gebruikt programming tools om te analyseren, big data analyseren en modellen en patterns te vinden. Hij is geïnteresseerd in grote schaal circulatie, atmosferische circulatie, seizoen en variaties in de seasonal en decadal variations. In grote schaal atmospheric properties. En uiteraard climate response to forcing from anthropogenic and natural sources. De interview zal plaatsvinden in het Engels uiteraard. We gaan zo meteen contact opnemen met Abdullah Fahad. We praten over klimaat. And I give a welcome to Abdullah Fahad. Are you there? Can you hear me?
Hi, I can hear you.
Thank you very much for being today with us at this
Sure, no problem. It's my pleasure.
Great. I have a lot of questions about your work and your study, your research. But we start with the first one. You detected a huge cloud hole on April the 3rd, south of Cape of Good Hope. At what latitude precisely did you detect it?
So it was detected by a NASA satellite named Terra. So the cloud hole was around 45 degrees to 60 degrees south in southern hemisphere. So basically in mid-latitude of south of the southern hemisphere.
Yes. What did you exactly see and why is it unusual?
So on April 3rd, our NASA satellite Terra that has a spectrometer known as MODIS, MODIS, so happened to be at the latitude and picked up data of that region, showing a big cloud hole in that area. So we saw there is like a band of clouds that's covering in the southern hemisphere latitude, but there was a big hole of clouds in that region. So in that region, around 50 degrees south to 60 degrees south, known as fiery frontiers or very storm region, because it's more of like a storm tracks region. So we have mid-latitude to high-latitude region, like 60 degree to 90 degree, where storms are very common. But if you come from like 40 degree to lower latitudes, the storm, like subtropical anticyclones. So anticyclones are very common. So seeing that cloud was a reason behind was a very strong anticyclone. And anticyclone is not that common in that 50 degree to 60 degree latitude because there is more stormy cyclonic activity more common in there. So we are seeing more of a opposite reason, like a anticyclone presence that's creating that cloud. So that was sort of an unusual activity.
Yeah. And what can be the cause of it?
So we can't say specifically because this type of event is not, it's not that it didn't happen before, but it is unusual because, as I said, the subtropical anticyclones happens in subtropical region, and anticyclone in higher latitudes are not that common. But with climate change, we know that with CO2 forcing increasing in the atmosphere, then the cyclones or the atmospheric subtropical high pressure are pushing toward polar region. And the storm tracks are also going toward more pole. So the anticyclone's activity, like sort of this type of event, anticyclone going to the high latitude, like 50 degree to 60 degree, are getting more common. And we can't necessarily say this exact event happened before of the climate change, but with more CO2 forces increasing and more climate change, this type of event will occur more. So we can say that in future we might see more subtropical anticyclones. Part of the subtropical anticyclones type of event is more frequent over the mid-latitude and high-latitude regions.
Yeah. So you say that there can be a correlation of this huge cloud hole with the warming of the atmosphere on Earth caused by man-made CO2 emissions?
As I said, we can't specifically say that this April 3rd event of anticyclone being there is a man-made climate change effect, because it is not that when there was no climate change impact, like say 200 years ago, there was not that much of carbon dioxide in the atmosphere. There was still sometimes that severe erratic weather happened, or there are probably common anticyclone in that region. But now the frequency of anticyclone being there is getting more increased with CO2 forcing. So when I want to say that is this type of event is going to increase, or frequency going to increase because of the carbon dioxide or man-made global warming? Yes. But can I say that that specific event was due to the climate change? With certainty, that can't be possible to say, because it is more of a weather event, and the climate change or climate event happens to be a longer time scale.
Yeah. On April the 11th and 12th, an extreme weather event occurred in South Africa near Durban and in the province KwaZulu-Natal. In 24 hours, 310 millimeters rain fell down, more than 1/3 of the normal yearly rainfall in this region. How do we explain this? And can there be a correlation with the cloud hole?
So yeah, I heard about that. I saw the news that there was a large rainfall event last month in April. And that because of that rainfall events, there was actually a lot of devastating floods impact. Even I saw one news that there is almost like 400 people died, and there's a large impact and devastating impact because of those rainfall and flood effects. So this type of severe rainfall is not that common in the southern. I believe it was in eastern South Africa, and there is actually a paper I saw today. Written by Pinto et al., and they claim that this type of event, that severe rainfall happening like 2 days, are going to be more frequent with climate change. As I said, this type of weather event we can't certainly say, okay, that specific event happened because of the climate change, because climate happened in a longer time scale. But that specific event is more of like a weather event. That depends on initial condition a lot, the atmosphere state, that initial condition surrounding things that comes together to create that type of event, like a devastating flood or like severe rainfall that leads to a flood. So what you can say that does that type of flood is correlated to the cloud hole that we saw due to our anticyclones. Again, the large-scale circulation can be drive both of them, but not necessarily they are correlated. They will be correlated, but I don't think that there is like a correlation and causation at the same time.
Yeah. We see that the warming of the atmosphere is almost one degree Celsius in 100 years. So it's very gradual.
Yeah.
And how can we see this kind of very violent events? How it's difficult to see the correlation between something which is really very gradual,
right,
and homogeneous in the atmosphere, and this kind of really disasters and very violent events.
Yeah.
Can we explain this, that this is not gradual? I mean, the warming of the atmosphere is very slow. It increases, of course. The temperature is increasing. The average temperature is increasing, but in a slow line, let's say. And these events are.
I don't think I understood your question correctly. Can you specifically say what?
The point is, we see that there is a warming of the atmosphere. Let's say the Earth doesn't get warmer, of course, because the sun gives the heating to the Earth. But then the problem is that due to the greenhouse effect, it's not possible for the Earth to cool down in a normal way, because normally we get the heating during the day with the sun, and in the night, then all the heating, there comes a balance. The problem is that this balance actually has been disbalanced after the revolution. But this is a very gradual process. It's not a...
Right. So exactly.
And these violent events are...
Yeah. So I think people mix up the weather and climate events. So when you say climate change, the weather events, severe weather events such as floods, even the droughts, for example, we had a study a couple of years ago. There was a severe drought in Cape Town from 2015 to 2017 that leads to almost a Cape Town Day Zero drought that are known as Cape Town Day Zero drought, that the water shortage was so severe that there was no water available in the Cape Town, almost no water. And again, we found that with climate change, this type of event increases. So it's gradually warming, and this type of severe event actually increases number of things. So this type of severe flood and rainfall happened before, but now it's happening more. So that is a problem, actually. So with global warming and atmosphere warming and the ocean feedback to that warming increases this type of events more frequently, especially in some region like high latitude, like, for example, global warming with global warming. For example, Netherland has a temperature increase 1.7 degrees Celsius, I believe, in last century, and that increases the severe heat waves and rainfall and floods and things like that that associate with climate change. Although these are weather events, but they increases with climate change more frequently.
Yeah. Can you tell us more about the so-called sudden stratosphere warming? Can we correlate this sudden stratosphere warming with the man-made CO2 emissions?
That's a very interesting question for me, because right now I'm actually working on a paper, a study that actually looks into that, specifically sudden stratospheric warming. So sudden stratospheric warming basically happens when the stratosphere in the polar region actually warms very quickly compared to its natural state. So sudden stratospheric warming, there are several papers, including our, that looking into how carbon dioxide influencing the polar region in the stratosphere and troposphere. We found that with carbon dioxide increase in the atmosphere, that sudden stratospheric warming events, again, sudden stratospheric warming event, actually frequency of the sudden stratospheric warming increases. So with carbon dioxide increase, the troposphere is supposed to be warm, but the stratosphere is supposed to be cooled down. However, in the northern hemisphere stratosphere, in the polar region, where the SSW or sudden stratospheric warming events actually occur, we found that with CO2 warming, that part does not cool down because of the troposphere-stratosphere coupling and their physical mechanism happening. So in summary, because of the carbon dioxide increase, the sudden stratospheric warming, actually, the frequency of it increases in future. And even in our past decade, we found that the sudden stratospheric warming actually increases the number of it. Yeah.
Yeah. So, but the point is, we have this polar vortex, which takes part in the troposphere for a part, and also in the stratosphere. And the polar vortex in the atmosphere, in the troposphere, of course, is influenced by the CO2 concentration. But the polar vortex in the stratosphere, is it also influenced by the CO2? I mean, it's influenced by the polar vortex laying down?
Yeah. You're exactly right.
How is it possible? The question is, how is it possible that we can influence even the stratosphere, which has a very different composition, and it's completely different?
Sorry, you're right. So As you know, so basically, as you say, the polar vortex, there are two polar vortexes actually. One is the troposphere, which basically from 0 to like 5 kilometer to 10 kilometer, like in the troposphere. And then we have stratosphere right above that as a stratospheric polar vortex. Now, we know, we understand that how the CO2 or land warming can directly influence the troposphere polar vortex. But the stratospheric polar vortex actually gets influenced by the CO2 very well also. One way is the Brewer-Dobson circulation. So we have the atmospheric circulation in the troposphere known as the Hadley circulation. So that goes tropics like 0 latitude to high latitude and near pole. And mid-latitude there is like a circulation we have known as the Hadley circulation. Then we have a Ferrel cell. But in the stratosphere, we also have a Brewer-Dobson circulation where atmosphere that circulation goes from tropical latitude to high latitudes in the polar. That's one way to do it. And second is we found that with CO2 increase, the tropical heating increases. And that heating actually gets transferred by wave activity that goes to mid-latitude region, like 60-degree region. And that troposphere and stratosphere in the mid-latitudes actually interacts with each other by wave activity, known as the stationary wave or Rossby wave. That wave activity basically transfer heat from mid-latitude troposphere to stratosphere in the pole. And that changes how polar vortexes in the stratosphere, the temperature changes. If the temperature increases, the polar vortex actually weakens, and things like that influences the sudden stratospheric warming. And that is one mechanism, one strong mechanism that's how the stratospheric polar vortex gets changed. But there are certainly other ways also, like troposphere vortex and the stratosphere polar vortex interacting with each other. That's also how the stratosphere polar vortex can be influenced by it.
Yeah. So we are creating problems not only in the troposphere, but also in the stratosphere. This is, I don't hear this issue being discussed, actually.
Yeah, one reason is that
it's strange because I think we are causing a lot of problems, not only in our troposphere, but even in the stratosphere.
Yeah, it is true. But one reason we don't necessarily, hear much about it because we, the most of the weather that affect us directly is from troposphere. So, but we actually changes the stratosphere too. With CO2 increase, the stratosphere actually cools down other than the polar vortex. So now, if the polar vortex changes, that interacts with the troposphere as a positive feedback and changes the troposphere and the near surface temperature too. For example, with polar vortex change, the cold event associated with polar vortex in the troposphere also gets influenced by the stratospheric polar vortex. So you have more, splitting polar vortexes and creates more of a cold event over the northern hemisphere, high latitudes over the USA, Canada, and northern Europe and Russia. Yeah, and actually it happens in both hemispheres.
Yeah. The last years, they've noticed some stratospheric warming really of 40 degrees. Incredible. Yeah, very, very huge.
Yeah.
Can this be caused by the polar vortex in the troposphere? Do you think in such a high level? I mean,
can you? I think
because
I
read in the papers. I followed these issues since a couple of years, maybe sometime, and I read that the sudden stratospheric warming that has been detected the last years. Sometimes it is something like 40 degrees difference. I mean, the stratosphere is very cold, but then suddenly it changes and it gets a warming of 40 degrees. But can this be caused by this polar vortex of the troposphere? Such a huge increase, a sudden.
Right. So it can be. It's not the troposphere polar vortex that making that differences is one way. Another way that prominently that we found in our paper, actually we still haven't submitted that, but we found that the tropical heating of our Pacific Ocean, that heating due to CO2 increase, that there is a heating increase over the tropical Pacific Ocean, and that heating actually transfers to pole wave activity. And as a combination of both of those and a couple of other reasons actually can create this type of huge anomaly that we can see in the last years. Yeah.
Yeah. And how can it be that the tropical regions are more, the atmosphere there is more warmed than at other regions? Because we see that the industrial countries, they are emitting a lot of pollution and particles and CO2. And why do we see that just the tropical regions see a bigger increase in temperature?
Right.
How can it be?
So when you talk about like global warming, people always talk about like the Arctic, like in the pole we have more warming, and tropics in the tropical region there are actually warming also, actually a lot of warming, but it's not necessarily in the lower or surface. It is in the upper troposphere. So there is a Clausius-Clapeyron relation. So with more carbon dioxide, the water vapor actually, because we have more radiation in the tropical region, right? So because of the more heating, the warm air rises in the tropical region and descends or goes down back in the pole region or in the high latitude region. So with more warm air rising, if we have more heating due to the carbon dioxide, we have more radiation in the tropical region, and that traps more heating, and that heating makes more water vapor in the atmosphere. And if we have more water vapor, that actually traps the heat more because water has more heat capacity than atmosphere or air, right? So that water vapor heat capacity warms the atmosphere as a positive feedback and creates more warming in the upper troposphere. So in the Arctic or in the pole, we have more heating in the surface, near surface where we have ice. But in the tropical region, for example, in the tropical Pacific over the land, we have in the upper troposphere, like 200 hectopascal, for example, 12 to 14 kilometer above surface, we have more warming in there. So it creates sort of a diagonal warming pattern. In the tropical region, we have upper troposphere warming, where in the pole, we have near surface warming or Arctic amplification.
Yeah.
So the atmosphere.
So we are measuring an increase in temperature, which is really not homogeneous, because in the tropics we are measuring the higher troposphere, and on the poles we are measuring the surface temperature.
Yeah, we are measuring everything, but those are the regions getting more influenced by the change of the climate. And this is because of how our Earth is actually taking the radiation, because radiation is more over the tropical region, right? Over the tropical region, we have more heating, direct sun radiation, whereas in the high latitude, there are less radiation directly going in there. So more warm air in the tropical region, and warm air gets lighter, and it gets in the upper troposphere. And the circulation known as like heavy circulation transfers that warm air to the pole, and it cools down and descends back to our surface. That creates the high pressure systems in the subtropical to mid-latitude region. So these are the regions that are getting more influenced by, but we are looking into all of those regions, not necessarily we are focusing on specific things. Yeah.
Are you studying the influence of sun radiation on climate on Earth?
This is a very basic question. I think a lot of people actually don't understand. Thanks for asking that question. Actually, sun's radiation and how sun's radiation gets distributed on Earth is like the center of a climate model. So when you look at the climate model, first thing we need to do is how that sun's radiation gets distributed over Earth. So when you talk about climate change with carbon dioxide or greenhouse gas, the distribution of the sun radiation gets changed, and that radiation change basically creates climate change, because on normally, if we don't have greenhouse gas changes very quickly, the sun radiation wouldn't be changing that much over year to year, right? There is a solar cycle, obviously, like 11-year solar cycle, but the changes to that a solar cycle to solar cycle average is not that much. But because of the carbon dioxide and greenhouse gases, those creates a very the distribution of the sun's radiation gets very changed, and because of that, the heating pattern and the tropical troposphere to upper troposphere and the polar region gets also the radiation distribution gets changed. So yeah, this is basically the heart of a climate model and the physics of the climate model, that how the radiation gets distributed on the Earth's surface.
Yeah. Some influencing people inside the IPCC suggest the climate engineering, for instance, stratospheric aerosol injection or so-called sun dimming, could be the solution to the warming of atmosphere on Earth. What do you think about it?
That is a very interesting question. When I was doing my PhD, I was actually looking into it, and because I found that is a solution. But I think personally, I mean that's one solution. That is not the solution. There are for a couple of reasons. When we change the stratospheric weather and climate and the troposphere weather climate by injecting our own aerosol, that will have also negative feedbacks in a couple of regions. For example, the climate change impact due to the radiation change due to CO2 increase and greenhouse gas is not homogeneous in all regions, right? So if we inject aerosol in the atmosphere, in the stratosphere, let's say, and we dim down the sun to cool down the Earth, so that the sun radiation doesn't come to the Earth's surface much, so that we have a less heat in Earth and we cool down the Earth. But that will change the atmospheric circulation, how the precipitation will work. So I think one study showed that there is a major changes in the tropical India and China if we inject stratosphere aerosol. Also, the question becomes, where do you want to put aerosol, right? Because if you homogeneously put aerosol over everywhere, all over the region from tropics to pole, the temperature gradient and everything will be messed up. So that might be a lot of tampering with the Earth system. That I don't necessarily think that is the best idea to as a first step. To reduce the impact of climate change, we definitely should reduce the CO2 footprint first, and try to minimize our man-made influence first, rather than finding a solution or doing the geoengineering. It might be a solution in future if there is no other solution, but right now I don't think that is the best or the only idea.
Yeah. Do you think that China and Russia are doing climate engineering at the moment? Because China is doing this the reason is to increase rainfall in some regions.
Right.
But do you think that this is already taking place in some countries?
I think so. I think at some extent people probably already testing it with aerosol, everything. But again, as I said, that might have a devastating impact. And because of the climate circulation, for example, if China is using it, the impact of it might be in another region because of the influence of how that because atmosphere is a very delicate system and very chaotic system, connected to each other. The butterfly effect that connects every small thing in one region can change or very severely change in other region. So I think we have to be very careful, and it needs to be very thoroughly studied before we implement in a real case. The aerosol influencing,
Is there some cooperation at the global level on this issue? I mean, because we have the North Pole. If you can cause rain in the North Pole instead of snow, then you can have huge effects, huge consequences. And are we sure that this is not happening? I mean, also in the Siberian regions, can we control this?
Are you saying that can you control the aerosol injection?
Yeah.
I personally, as I said, that I don't think that's a good idea. If some government is already doing it, I don't necessarily know. There is a community out there, they are advocating for it in the science community. They are definitely doing research on it, but not necessarily advocating that, this is the solution for the climate change. But as I said, that can be a solution if we can minimize the impact of it. And if we have a very hard study, if we inject, saying that, if we inject aerosol in the stratosphere or atmosphere, this will be the change in future. and that the changes we are doing by injecting aerosol. And if everyone agrees to do that change, then we can, inject aerosol. But randomly or sporadically doing it might be more harmful than we will do good. So yeah, we have to be very careful if we want to do it. As I said, that shouldn't be our first step to solve the climate change problem. It should be like, later, or we need more study before it can be implemented.
Yeah, there is also the risk that we can destroy the ozone layer in the stratosphere by injecting sulfides.
Yeah, there are several consequences. Actually, there are lots of consequences, and specifically putting aerosol. Where do you want to put it? There's so many questions. There are so many moving parts that needs to be figured out, because putting aerosol in the tropical region versus in the subtropical region, our ocean versus land, will have a very, very different result. And no, we can't certainly say what will have what impact. For example, one way to see that is when the volcano happens. Like, for example, a couple of months ago, I think there was a Togo volcano, and because of the volcanic eruption, there is the aerosol in the stratosphere. And because of that, there is like a global cooling. Wherever the aerosol is, the sun's radiation goes back less on the Earth's surface. As a result, we have less heating and the radiation. Temporarily for like a year, we'll have a less temperature increase, or even a bit of cooling because of that volcanic eruption. But that eruption is not necessarily good for a lot of reasons, because it messes up the Earth system normal behavior, and that can have a large impact later. So we have to be very careful before we are doing it by manually.
Yeah. What can we say about the sun flares frequently occurring in these days? What do we know about these flares influencing weather on Earth and eventually climate in the long run?
Right. As I was mentioning before, that the sun, there's a solar cycle, and the sun flare actually definitely has a lot of impact in the weather and climate. Sun is the main the driver of the weather and climate in the Earth. But the sun radiation, there is a solar cycle, 11-year solar cycle. In that solar cycle, there is a sun radiation maxima and there is a minima that happens like in 5 to 6 years. But over years to year, the sun's solar flare actually happened to be, I think there is a study from 2003 from NASA Goddard in my institution. They found that there is a trend increasing of the solar flare over the past years. So, but that increase is very non-significant. I think it was 0.05%. So not even 1%, 0.05%. The solar flare increasing over the years. So that has nothing to do with greenhouse gases or anything. But that study basically helps us to separate the influence of climate change radiation changes versus the solar flare radiation changes.
Yeah. What do we know about the influence of thermo-aligned circulation on the warming of the atmosphere?
Right. So I believe you're talking about thermo-aligned circulation in the polar region. So the thermo-aligned circulation basically happens because with cold wind, so we have a more warming in the tropical region, and in the pole we have because of the less radiation, we have more cold, right? So the temperature gradient, because of the cold, there is a more windy circulation, but it's a cold wind. And the cold wind creates more ice, and that ice from water, that creates ice. And because of the ice doesn't have any salt, that salt basically drops down to the beneath the ocean water of that ice in the polar region. And because it gets more saltier with more ice forming in the like a surface of the ocean, that dense cold water kind of drops down to the ocean surface to deep ocean, like in that it gets down at several meters. So because of that, it creates the thermo-aligned circulation that basically moves heat and transport energy from tropics to pole or mid-latitudes to polar region. Because of the climate change of the warming, the ice basically melts down and it changes the salinity, and it creates a less denser water in the polar region. And because of that, it creates a positive feedback of more heating getting transferred to the tropics to pole, and more ice, decreasing, more ice melting, and that melting ice creates a less saline water and creates a less denser water, and makes the mixed layer depth more shallow. And that pattern, basically the Arctic circulation, like when you talk about the climate change, the atmosphere gets more warmer very faster, but the ocean gets slower because ocean has a large heat capacity. So ocean temperature moves slowly. So with climate change, when you have more warming in the atmosphere, the ocean takes the heat. So there is a heat uptake in the ocean from the atmosphere. So as a result, although we have a lot of carbon dioxide in the atmosphere, we still don't feel that much warming or climate change impact. We still don't have that because of the ocean, because ocean took that hit. But problem is that heat will come back to us later in the atmosphere as the ocean heat feedback. And because of the climate change and Arctic amplification, there is a study that shows that in the southern hemisphere, the southern ocean actually played a bigger role reducing or delaying the impact of climate change. And because of the thermohaline circulation changing in future, we will have a more instantaneous impact of climate change rather than a delayed down impact of the climate change. So that's very concerning.
What is difficult to understand for the layman is we think we know that the Earth, there is more ocean than Earth, and you should think that the oceans can compensate all the troubles caused by man, pollution and emissions. And also I was thinking about the thermohaline circulations in the oceans. Let's say this circulation that takes place, it starts from the Gulf and then it goes to the north, then it sinks and it goes to the Pacific, and it takes really 1,000 years before it is reaching the beginning again. So you should think in this 1,000 years, the oceans should be able to balance in a way the problems caused by us and caused by a minority actually, because we are polluting a lot, but there are regions where nothing happens and people are so poor that they don't have industry and not enough to produce so much CO2. This is difficult to understand.
Yeah, it is very difficult, to be honest. But again, I think we might be asking the ocean too much, as ocean is doing it at its best already. So let's say we don't have ocean in there. We don't have any water or any ocean. We just have land all over the globe. And we are putting lots of CO2 in the atmosphere. What will happen then? In that case, the atmosphere will, the warming in the atmosphere will be very instantaneous. It will be very warm very quickly, and the climate change impact will be very much visible. Not like 10 years, 20 years. I think you could say like in 5 to 6 years, we could see a devastating climate change impact just because we don't have an ocean. And because of the ocean, what happens is that the ocean takes that heat from atmosphere to ocean intake, and that heat from tropics to pole, there is atmospheric circulation. So there is a oceanic circulation too that transfer heat from tropics to pole, like the western boundary current, and there is a marginal circulation too. And that heat transfer is very slow in the ocean, that goes from surface to goes deep water and that comes back to surface. That is very slowly doing. And because of the thermohaline circulation changing with the climate change, at certain point, those heat that got trapped inside the ocean in the deep water will come back to Earth's surface, especially in the polar region, from tropics to pole, and that will have a devastating impact. So the problem with only atmosphere is that it gets it responds very fast to climate change. But good thing is if we respond, if we want to change something, the atmosphere will also respond faster. The problem with ocean is we are changing the ocean very slowly. So if we want to change again as to make it better and reduce the impact of climate change in the ocean, that will be also slower, right? Because it took a long time to get warmer. It will also take a long time to get cooler. Whereas in the atmosphere, it's very instant. And also you can see with on the daylight changes, in the day it is very warm because our radiation is getting more from the sun, whereas overnight it cools down. But in the ocean, the cooling down and warming is very slower because of the water has a more heat capacity than the air per se.
Can we measure an average increase in temperature of the oceans? The same as we do for atmosphere, because we say now in 100 years we had an increase of 1 degree Celsius.
So when we're saying 1 degree in 100 years, we are talking actually as a coupled system, not only atmosphere. We consider or we care about atmosphere because we live there, but when you talk about 1 degree changes, we are talking about how atmosphere, ocean interacting with each other. They're doing their own work. Then how much atmosphere actually changing in 100 years. So when you run the climate model, it's a coupled model. It's known as the global coupled climate model. So that coupled model actually interacts the atmosphere. It has an interactive atmosphere-ocean model. And that the physics basically does everything. The radiation goes in the atmosphere, in the land, and it goes also inside the ocean. And because of that, we can also measure how much ocean will be changing. So as I said, the deep water heat capacity actually increasing because heat content is increasing, not heat capacity, sorry. So that heat content is increasing in the tropics to pole, and the heat content comes back to surface and increases the sea surface temperature. And the sea surface temperature warms the atmosphere. So in 100 years, that ocean is more main driver how our climate will be changed rather than our atmospheric component. So we focus on the atmosphere as a result, but driver is mostly, the culprit is mostly the ocean. But again, I don't want to say culprit because atmosphere in the first case that is warming the ocean. Yeah, right. So we are warming the atmosphere, and atmosphere warming the ocean, and the ocean is warming the atmosphere again. So it's like a vicious cycle.
Yeah. Now, thank you very much for being with us this evening. And thank you for your interesting words. And I would say thank you and goodbye.
Thank you. My pleasure. Have a good one. Bye.
Thank you. Bye-bye. Broadcasting of Voice of the Town with Silvia Terribili. Our guest was Dr. Abdullah Al Fahad. He's working at the National Aeronautics and Space Administration, Goddard Space Flight Center, and we talked about climate, the most important issue nowadays.